You know that feeling, right? You're staring at a generic Java error and just wishing it could tell you what really went wrong with your logic. Well, if that's you, you're in the right place. Today, we're going to completely transform your error handling by creating custom exceptions. And trust me, this is a huge skill, not just for writing clean code, but for absolutely acing those technical interviews. Let's get started.
I mean, really think about it. A null pointers exception. It tells you something is missing, sure, but it doesn't tell you why. Was it because a user account couldn't be found? Or maybe a product is out of stock? The standard exceptions just don't get your specific business rules. And that's the exact problem we're going to solve today. So, here's our game plan. First, we'll talk about why the standard exceptions often aren't enough. Then, we'll dissect what a custom exception is actually made of, build one from scratch, see how to use it, and finally, we'll go over the golden rules you've got to remember. All right, let's start with the why. I mean, why go through the trouble of creating a whole new class just for an error? Well, the answer comes down to two simple words: clarity and precision. Just look at the difference here. On the left, catching a generic exception is, well, it's like having a vague symptom. You know you're sick, but you have no idea what's wrong. But look at the right. Imagine you have a custom exception called InsufficientBalanceException. Right away, that catch block tells you exactly what business rule was broken. Your code basically documents itself, and your debugging gets way, way faster. So, how do we create these super specific error signals? It's actually not about building something totally from scratch. It's more like inheriting some superpowers from a class that Java already gives us. So, what is it we're actually building? A custom exception is really just a plain old Java class that you create. The magic happens when you make it a child of an existing exception class, like exception or runtime exception. It's through that inheritance that our class suddenly gets all the powers it needs to act like a real error. And this right here, this is the key to the whole process. That simple little phrase, extends exception. That's what turns a regular, everyday class into a powerful error handling tool. It's you telling the Java compiler, hey, treat this class like a proper exception, and it gets all the features from its parent, just like that.
All right, enough theory. Let's get our hands dirty. Building your own exception is actually surprisingly simple once you see the blueprint. So let's walk through it, step by step. See, it really just boils down to these three simple steps. First, you just create a new class. Second, you make it extend exception to give it those superpowers we talked about. And third, you add a constructor. That's how you're going to pass in your own custom error message. That's the entire blueprint right there.
Now for the secret ingredient, the super call. This is a really important point. When you create your exception with a message, how does your class actually hold onto that message? Well, it doesn't. It passes it up to its parent, the main exception class, which already knows exactly what to do with it. Calling super message is kind of like handing a letter to a mail carrier. It makes sure your message gets to the right place to be handled correctly. Okay, so we've built our custom exception class. Now what? How do we actually use it in our code? This part involves two keywords you already know: throw and catch. So when your code hits a point where a business rule is broken, like in this example, trying to process a zero value, you use the throw new command. This creates a brand new instance of your custom exception and basically shouts, hey, a very specific error just happened. And here's the payoff. You know, catching a generic exception is like casting a giant net into the ocean. You have no idea what you're going to get. But by catching your Naveen exception directly, it's like using the perfect lure for one specific type of fish. You can write code to handle that one single specific error, which makes your whole program so much more robust and predictable.
We've covered a lot of ground, so let's boil it all down. These are the absolute essentials, the things you'll want to have locked in, especially when you're in an exam or a technical interview. Let's just hammer these 5 rules home. 1. Your class has to extend exception. That's non-negotiable. 2. You need a constructor to take in your custom message. 3. You have to call super to pass that message up. 4. Use throw new to actually trigger your exception. And finally, 5. Catch your specific exception type to handle errors with precision. Got it? Good.
Okay, one last but really crucial point: checked versus unchecked exceptions. This comes up in interviews all the time. Think of a checked exception, the one that extends exception, like a fire alarm. The compiler sees it and forces you to have a plan. It makes you use a try-catch. An unchecked exception, which extends runtime exception, is more like a surprise pop quiz. You're not expected to plan for it, but it can still happen. So for your exams, remember, use checked for predictable errors you can recover from and unchecked for those unexpected bugs.
So the big takeaway here is that custom exceptions completely change the game. They take your error handling from being generic and vague to being specific and meaningful. Your code becomes cleaner and so much easier to maintain. So I'll leave you with this. What business rule in your next project are you going to protect with a brand new custom exception?